In this lesson, we are going to do a little bit of practice from section 8.1 in our book. Those problems cover solving quadratic equations by factoring and solving quadratic equations by using that square root method. So before we start, I'm just going to put the notes from our class up here. So steps for solving by factoring. The very first thing you always need to make sure is that you set your equation equal to 0. So you need to have equal 0 before you can do anything. Once you've done that, then we'll need to factor, then set each multiplier equal to 0, and then solve. So let's go ahead and look at problem number 1. So the very first thing we need to check is it set equal to 0? Since it is, we can go ahead and factor. So there are 3 terms, so we factor this using the AC method, if that's a method that you're used to. So you always put your 1x up top, so the a value and the variable you're using. Then your a times your c is up here. And your b value goes down here, which is that 13. So now we want to find what multiplies to give us this top number. And then we want to find what adds to give us that bottom number. So we write out the factors of our 36. I always recommend starting off with the number 1 because you know it'll go into all of your numbers. So 1 into 36 is 36, and then the number that comes after 1 is 2. So 2 goes into 36 18 times. After 2 comes 3. 3 times 12 gives you 36. After 3 comes 4. 4 times 9 is 36. After 4 comes 5, but 5 doesn't go into that 36. So then after 5 comes 6, and 6 times 6 does equal 36. Once you get to a number on this right-hand column, you know that you have found all of your factors. So since the next factor after 6 would be 7, well, we've already written 6 down here, so it was already there. But let's say the next factor would have been a 9. Since we already have 9 written there, we know that we were finished. And there will be some better examples here in the future. Plus, there is a video on the AC method on my YouTube channel you can also check out. So when you look at all of these pairings, you look for the one that will also add to give you that 13. And you do your check. Does 4 times 9 give you 36? It does. Does 4 plus 9 give you 13? It does. So now we are going to write out our factored portion. We have x plus 4 because that 4 is considered positive, x plus 9 because that 9 is considered positive. And you don't have to write those ones there. The reason we put the a value up there is when we get to some problems that are a little trickier, it'll help us out with those. So now we still have to solve. So remember, when you solve, you take each multiplier. So this x plus 4 in parentheses is a multiplier, x plus 9 is a multiplier in these parentheses. So you set each of those equal to 0. And then the very last step is going to tell you to solve. So to get this x by itself, you would subtract 4 from both sides to get negative 4. And then you would subtract 9 from both sides and get negative 9. If you were to plug either one of these answers into the x's in this equation, then you would end up getting 0. But you would have to plug the same number. So 4 for the x squared and the x, or 9 for the x squared and the x. Okay? All right, so as one very quick reminder that we learned in class, when you are solving these quadratic equations, you are always solving for the x intercepts. And remember, those x intercepts are going to be where your graph crosses that x-axis. Okay? So let's go ahead and scooch on to problem number 2. Very first thing we need to do is make sure that this is set equal to 0. Since it's not, we need to get this 5 out of here. So the only way to make that 5 a 0 is to subtract that same amount from it. And what we do to one side of the equation, you have to do to the other. So that gives us x squared minus 3x minus 40 equals 0. And then we'll do the AC method over here. So I'm not going to explain step by step exactly what I'm doing here, just because this is something I've already explained up here, and I have another video on my YouTube channel where you are able to watch that if you're confused as to how I got something. So for our factors of negative 40, don't worry about the negative just yet, but you know that when you multiply two numbers to get a negative, one is positive and one is negative. So we know that this is going to be what our signs are. So you know one's positive, one's negative, but when you're writing out the factors, only look at them as if they're positive. So 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, and then 5 and 8. After 5 comes 6, but it doesn't go into 40. After 6 comes 7, but it doesn't go into 40. And after 7 comes 8. Now since 8 is already written in this column, we know that we have found all of our factors. And so since one is positive, one is negative, then you're going to end up having to subtract two of these in order to get a negative 3. Remember the rule: when you are combining two numbers and one is positive and one is negative, you'll end up subtracting them. So 5 and 8 is the pair we will use. And in order to get that 3 to be a negative, you would need the larger number to be negative. So now that before we go on, let's make sure we check it. So 5 times negative 8 does give us a negative 40. 5 plus negative 8 does give us a negative 3. Always make sure you do your check. So now let's go ahead and write out these multipliers that we found. So the 5 is positive because it's understood to be a positive, as nothing's written. And then we would do minus 8 here because that 8 is a negative. So now you set each multiplier equal to 0, and then you would solve. So I would do minus 5 from both sides, plus 8 on both sides, and that would give you answers of negative 5 and positive 8. Okay. So now let's go ahead and look at number 3. Number 3, we need to get this equal to 0, so we're going to do the opposite. So since that's a positive 2, we'll do a negative. But notice that there are no like terms over here. Since negative 2 is not a like term with either one of these, we are just going to write it in place where it should go in descending order. So since this 2 doesn't have any x's in there, we'll just put it down here at the end. So now we will go ahead and do our AC method. This one is going to be slightly different because our a value is a number that's other than 1, and our other two problems just had a 1 here. So you still put your a and the variable you're using. Up here still goes your a times your c, so 6 times negative 2 is negative 12. And then your b value goes down here, which is a negative 1. All right, so now your factors of negative 12, one's positive, one's negative, and you're going to say 1 times 12, after 1 comes 2, 2 times 6, and after 2 comes 3, and 3 times 4. So now 3 and 4 are going to be the numbers we're looking for, and in order to make this add to give us a negative 1, you want the bigger number to be that same sign. But now notice that there is some simplification that we can do. So notice that 6 and 3 both have a number in common. You can divide them both by 3. So this would end up giving us a 2x over 1 because 3 goes into 6 2 times, 3 goes into 3 1 time. So this is actually the fraction we're going to use. And then over here, these have a 2 in common. So 2 goes into that 6 3 times, so that'll be a 3x. 2 goes into negative 4 2 times, and don't forget that it's a negative. So those are the, that's the fraction we're going to use for that one. So we have 2x plus 1 and 3x minus 2, and they're still set equal to 0. And then 2x plus 1 equals 0, 3x minus 2 equals 0. I highly recommend that you do not try and do this part in your head. I know it's real easy up here just to say that their signs are just going to be the opposite of whatever it is when you set it equal to 0. But here it's easy to make some simple mistakes. So just go through and do the steps just in case. It is worth it. So get rid of your addition and subtraction first. So that gives you 2x equals -1. And then you'll divide both sides by 2 to get an answer of x equals -1/2. Then add 2 to both sides over here to get 3x equals 2. Divide both sides by 3 to get x equals 2/3. So our answers there are x equals -1/2 and x equals 2/3. So now on problem number 4, notice that there are only 2 terms here. So it is set equal to 0, but over here there's only 2 terms. So that means that we are unable to use this AC method with the x that we've been using the whole time. So we need to look, and the first step in factoring is always to see, do you have a greatest common factor? Meaning, is there something that these 2 terms have in common? And you want to find the largest number and number of variables that they have in common. So between 3 and 12, you know that they have a 3 in common. And if this one has 2 x's, this one has 1 x, then the most number of x's that you can take out of both of those is just 1 x. You couldn't take 2 because this one doesn't have enough to take 2 away. So once you have found your greatest common factor, you will open your parentheses, and to get what goes inside of that set of parentheses, you will divide each of these terms by your greatest common factor. So I divided both of those by that GCF of 3x. So when you divide, 3 divided by 3 just gives you 1. You can write it if you want to, but you don't have to. And then x squared divided by x. Remember the rule, when you divide your bases that are the same, you subtract the exponents. So 2 x's, and then you got 1x down here. 2 minus 1 is just going to give you 1x, and that goes up here at the top. Then 12 divided by 3, that would give you a 4, and notice that it's a negative because it's a negative 12 divided by a positive 3. And then if you've got 1x up here, and then you divide it by 1x down here, well, those x's end up canceling, and so you have no x's left. In order to double check yourself, if you would like to, you can always multiply this back out, and if you get what you started with, then you know that you did it right. So now we have found our multipliers. 3x is considered a multiplier because it's multiplying by something. And then x minus 4 is also going to be one of those multipliers. So you're going to set both of those equal to 0 and solve for x. I'm going to divide each of these by 3. And anytime you have 0 divided by something, that's going to give you a 0. And then add 4 to both sides here to get x equals 4. Okay. So now let's look at problem number 5. On problem number 5, we are going to have to make sure we have this set equal to 0 first. So I'm going to subtract 2x from both sides. And when I do that, I end up getting, oh, these should all be y's. Sorry about that, guys. So this should be a y, and that should be a y. Sorry about that. So we're subtracting 2y from both sides. So to make sure we're not confused, I'm going to rewrite this problem. So you have y squared plus 2y minus 36 equals 2y. Again, I apologize about that. So subtract 2y from both sides, and that gives you y squared minus 36 equals 0. Okay? So now, in order to factor this one, notice that there's only two terms, so you can't use that AC method, which is using this x up here. And there is no greatest common factor. There's no number that both terms have in common. This term has two y's, and this term only has no y's, so you can't take any y's out. So notice that they're both perfect squares, meaning something multiplied by itself to get this. So when you have the difference of two perfect squares, you are going to use that car method. And all of these factoring methods, I do have videos on my YouTube channel that go a lot slower. You are more than welcome to check those out. So you draw your, what I call the two cars, which are your two sets of parentheses. You've got a good car and a bad car. And you find what times itself gives you y squared. That answer is y. And then you find what times itself gives you 36. Well, that answer is 6. So if you were to multiply this back out, you would end up getting y squared minus 36. So now you set each of those equal to 0, and then you solve. So you would get answers of y equals -6 and y equals +6. But if you wanted to, you could also write your answer as y equals ±6, okay? Because that's saying that your answer is both a +6 and a -6. All right, so now that we have gone through and worked all of those problems, I'm just going to write my answers on here real quick. So -4, -9 for 1, -5, 8 for 2, -1/2 and 2/3 for 3. 4 is 0 and 4. 5 is, I'm just going to put the shorthand method of ±6, but if you had written it this way as well, I'm perfectly fine with that. Also on your test, instead of using the comma to separate them, if you were to put y equals 6 and y equals -6, and that was what you wrote on your answer space, either way works. I really don't care. I just don't want you to put parentheses around these, because then that looks like it's an ordered pair, and that's not what this is. All right, so let's go ahead and flip the page and look at this next problem. So notice that now they're asking us to solve by using that square root method. So I'm going to show our notes here for the square root method. They tell us to get the perfect square by itself first. So remember, your perfect square is what is being multiplied, or what you get when you multiply something by itself. So like x squared is a perfect square because x times x is x squared. Another example would be 16, because 4 times 4 is 16. 100, 81, all of those are examples of perfect squares. So then your directions are going to ask you to square root both sides, okay? Don't forget your plus or minus. When you do take the square root of something, you can either get the positive or the negative of it, so you always have to put your plus or minus. You need to solve if needed, so if the variable is not by itself, you need to get it by itself. And then simplify if you can, and we'll talk about that here in a few minutes. So our first step here says to get the perfect square by itself. So that variable squared right here, that x squared, is by itself. That means it's the only thing on that side of the equal sign. So now I'm going to go to step 2, says to square root both sides. So I'm going to do a square root here and a square root here. So that's going to give me the square root of x squared is just x, equals the square root of 24. But notice that step 3 says don't forget your plus or minus. So you need to make sure you have that plus or minus in front of that radical. All right, and the reason why we are just writing that square root of 24 is because there's no number that multiplies by itself to give us 24. However, We can go ahead and simplify this by breaking it down using our prime factorization tree. So we can break it down by 6 and 4. If you use 2 and 12 or 8 and 3, it would still work the same. And you circle your numbers once you have a common number between the two. So, once you have a prime number. Sorry about that, guys. So once you have a number that is prime, meaning it only multiplies by 1 in itself, that's when you're going to circle something. And so then, and I'm showing you the long way just so you have that little bit of a reminder of what we learned in that last unit. So I have 3 2s and 1 3, and this is what I misspoke of earlier. Let me see, it's kind of hard to see here. There we go. So we need 2, because that's what that index is there. We need 2 of the same number to release something from that radical. So I'm going to take 2 of those 2's and I'm going to pull them out as just 1 2. And then the 2 and 3 are going to stay inside of that radical because they don't have 2 of the same number. So I'm going to have that here. So 2 times 3 is going to stay down there as a 6. Now here's the question. The question is, are you going to put that 2 in front of that plus or minus, or is it going to go right next to that radical? So the answer is the 2 is going to go next to the radical. So you put the plus or minus in front of the 2. You will only put the plus or minus in front, the 2 in front of the plus or minus if you are adding or subtracting it from here. But if it actually comes out of the radical, it will go in front of that radical, okay? So I'll go ahead and write you guys a little bit of a cheat here, and I'll start using black because it seems like the lighting is trying to mess up here. So if you have a number, it's going to go here if you are adding or subtracting. So hopefully you can read my writing. So there's little arrows pointing to this little space right here. So it will go here if you are adding or subtracting that number, okay? It will go here in front of the radical but behind the plus or minus if you are either multiplying or you brought something out of the radical. So in this case, we brought that set of 2's out, so that's why it went out in front of that radical. So now bring your equals x down, so this would be your answer, that plus or minus 2 square root of 6. So again, I'm going to start using the black because for some reason my lighting is just going crazy on here. So on number 7, we look and our steps say to get the perfect square by itself. So this is our perfect square. You need to get it to be the only thing on this side of the equal sign. So we're going to have to get rid of that 3, so we're going to add 3 to both sides. That gives us x squared equals 9. Now, sorry about that. Now we can go ahead and take the square root of both sides since the perfect square is now by itself. Square root of x squared just gives me an x. Square root of 9 just gives me a 3. Do not be tempted to leave that as your answer as just a 3. Don't forget plus or minus. And now that we got just a whole number for our answer, it's easier for me to remind you guys that if you were to plug a positive 3 in here, well, 3 squared, 3 times 3 gives you 9. If you were to plug a negative 3 in for that x, well, negative 3 squared means negative 3 times negative 3, which also gives you a positive 9. So that's why we have to have that plus or minus there, is because whenever you are to square something, it's always going to make your answer be a positive. So it could be a positive or negative that you're squaring. Okay, so now on number 8, you have to get that perfect square by itself. So we need to get this x squared by itself. So we have to get rid of the addition and subtraction first. So we need to add 7 to both sides to get 2x squared equals 98. And then divide both sides by 2 to get x squared equals 49. Next, we're going to square root both sides, since that x squared is now by itself, to get x equals 7. And don't forget step 3 says not to forget that plus or minus. Alright, so guys, whenever you're using this square root method, you're always going to have that plus or minus in your answer space. Alright, number 9, to get that x squared by itself, you need to divide both sides by 2 to get x squared equals 12. Now we're going to square root both sides, because the x squared is now by itself, and that gives us x equals plus or minus the square root of 12. Don't forget about that. But notice that 12 can be simplified. We can do our tree here and get 3 times 4, and the 4 breaks down to be 2 times 2. So since I've already given you the reminder as to how all this works, I'm not going to write everything out, but I'm going to pull out a pair of 2's, and that 3 is going to stay inside of the radical. Now we've got to think, are the 2's that we pulled out, are they going to go here or here? Now since we are pulling something out of the radical, it will go right in front of that radical. If we had added or subtracted it from one side to another, it would have gone here. So our answer for this problem is going to be plus or minus 2 onto the square root of 3. So number 10 is a little bit different. We did one like this on problem number 16 on your notes. Remember that you may be tempted to go ahead and multiply this out twice to write it out and distribute, but remember the definition of a perfect square is what you get when you multiply something by itself. Well, this actually is x minus 5 squared is multiplying x minus 5 times itself twice. That's the definition of a perfect square. So that means the perfect square is already by itself, so you can go ahead and take the square root of both sides. Now when you take the square root of that x minus 5 squared, remember you look to see, do I have something that is the exact same under this radical, 2 of the same thing? You do. You have 2 of the x minus 5's, so they come out as just 1 x minus 5. So we learned in class that this 2 and this radical essentially end up canceling each other out, and you're left with just x minus 5 equals the square root of 3. Make sure you do not forget your plus or minus. So now we can't simplify that square root of 3, which is step 4, so now we look at step 5, solve. All right, so x minus 5, to solve it, we're going to add 5 to both sides. And then we have x equals 5 plus or minus the square root of 3. So the reason that we put the 5 in front is because we are adding it, okay? We only put the 5 in between these two if it was being multiplied. So now we have 5 plus or minus the square root of 3. So I know I said the last 2 steps kind of backwards. I said that the next step would be to simplify and then to solve. Really, those are just going to be interchangeable. Just make sure that your problem is in simplest form at the very end, okay? So now let's look at problem number 11. So you need to get the perfect square by itself, and this 9 is in the way. So we need to subtract 9 from both sides to get this x minus 5 squared by itself. So when you subtract 9, that gives you 44. And now you can square root both sides. So you get x minus 5 equals the square root of 44, and then you want to not forget your plus or minus. So my preference is just to go ahead and simplify this guy first, and then I can go ahead and move that 5 over. It really just doesn't matter. So that 44 is going to break down to 4 and 11. 4 breaks down to be 2 and 2. So I can pull out this pair of 2's as 1, bring down my whole x minus 5 equals, and since I am pulling these 2's out of the radical, they are going to go directly in front of that radical. And then the 11 stays inside because it doesn't have another one to pull it out. Now, get the x by itself by adding 5 to both sides to get x equals 5 plus or minus 2 square root of 11. All right, so now let's go ahead and move on to problem number 12. So we have the perfect square by itself, so now we can do the square root of both sides. That's going to give me 3x minus 2 because the radical and the exponent basically cancel each other out. And notice that only happens when they have the same root and exponent are the same. So equals square root of 48. Don't forget your plus or minus. So now we're going to break down that 48 to be 4 times 12. 2 times 2 is the 4. 3 and 4 is going to be 12. And then 2 and 2 is going to give me that 4. So now I'm going to pull out 2 sets of 2's. And when you do that, you just multiply them together. So that's going to give you a 4 and then onto the square root of 3. So I get 3x minus 2 equals plus or minus 4 square root of 3. In case I just blew your mind, I'm going to show that step since it's been a minute since we did this section. So I wrote out all 4 of the 2's I circled and my 3. And you have 2 of the same number, so I could actually pull out 2 sets because I had 2 2's here and 2 2's here. Remember, when something comes out of the radical, it comes out as just 1. And the 3 stays inside. And when you pull more than one thing out of a radical, or if you have anything in front of it, those are going to multiply together, which is how we get 4 square roots of 3. Now we're going to add 2 to both sides to get that x by itself. So we get 3x equals 2 plus or minus 4 square root of 3. Then we're going to divide by 3 on both sides. So that's going to give us x equals 2 plus or minus 4 square root of 3 all over 3. Okay? You cannot simplify the 3 with the 3 under the radical, and since these don't have number in common, we are finished. So your final answer is 2 plus or minus 4 square roots of 3 all over 3. All right, so now let's look at number 13. We're moving to an easier problem back from the harder ones we just did. Get the perfect square by itself. So you're going to divide both sides by 5 to get x squared equals 4. Then you square root both sides. Square root of x squared is x, and then the square root of 4 is 2, but don't forget that plus or minus. And so your answer is plus or minus 2. Your x is already by itself now, so there's no extra steps needed. Now, number 14. It looks like my numbering's wrong on the side. Sorry about that. So now on number 14, we have the perfect square by itself. So we're going to go ahead and take the square root of both sides, which is going to give us 6x plus 2 equals plus or minus square root of 48. And we already broke down 48 earlier. When we broke it down on problem number 12, we got 4 square roots of 3. So since we've already done all that work, I'm not going to redo it all again. So if you need to be reminded of how we did that, go back in the video to problem number 12. So 4 square roots of 3 is what I got. So we're going to rewrite our 6x plus 2 equals plus or minus 4 square root of 3. Now I minus 2 from both sides to get 6x equals negative 2 plus or minus 4 square root of 3. Then divide both sides by 6 to get x equals. Now before I move on, I'm going to remind you guys of something that we learned in that last unit with simplifying. So we've got a term here, and then one down here. So in order to simplify this, you need to have something in common between all 3 of those numbers in order to be able to simplify. So we're looking at this negative 2, this 4, and this 6, okay? So notice that they all have the number 2 in common. So I'm going to divide each of those by 2 in order to simplify. You cannot just simplify these first 2 and leave that 4 there, or simplify those and leave that negative 2 there. You have to do it to all 3. So you get negative 2. When you divide that by the common number, it gives you a negative 1 plus or minus. Divide that 4 by 2, it gives you a 2, and then bring your square root of 3 down. All over, divide your 6 by 2, it gives you a 3. So this is your final answer. Negative 1 plus or minus 2 onto the square root of 3 all over 3. All right, so let's look at this very last problem that we have here. It's problem number 15. The perfect square is already by itself, so you're going to take the square root of both sides. You get 2x minus 6 equals plus or minus square root of 52. So now I'm going to go ahead and break down that square root of 52. So I get 2 times, looks like 26. And then 26 breaks down to be 2 and 13. So now I can pull out a pair of 2's here. I'm bringing down my 2x minus 6. That's how I got that. Equals plus or minus. When my 2's come out, remember they go in between these. All right, so the only time they would go in front of the plus or minus is if we were adding or subtracting, but anytime something comes out of a radical, it goes directly in front of that radical. So those come out as 1, 2, and then you write your 13 still under the radical. There weren't enough to pull out. Now we add 6 to both sides to get 2x equals 6 plus or minus 2 square root of 13. And then you divide everything by 2. Remember, we are looking to see if we can simplify, and you're looking at those 3 numbers there. You can never simplify anything that's under a radical by dividing it by something else. You can only simplify a radical by breaking it down like this. So there is a number that they all have in common. 2 goes into all of them. So that would give you x equals 3 plus or minus 1 square root of 13 all over 1. Now let's talk about these ones here. Since this is all over 1, we know we can write that in a simpler form and just say 3 plus or minus and then the square root of 13. Since there's understood to be a 1 in front of this radical, you can write it or not. It really doesn't matter. I don't care. The only time I won't let you write a 1 is if everything is all over 1, because you should know that you can write it in a simpler form by just writing that top numerator. So I'm going to write it without writing that 1 in front of the radical, but again, I would accept either one of those answers. All right, so I hope that this practice has helped you with the square root method in factoring, and I wish you the best of luck.